Hi guys, how are you? All right, so this is practice packet pages 14 and 15. I apologize, I know there's a lot of glare on the whiteboard. I've tried like every lighting combination I can think of and it's just gonna keep glaring. So make sure you have your practice packet with you, and that way you kind of, if you can't see exactly what I'm doing, you can kind of follow along. All right, so let me move you guys closer. And come on, dude, focus on that. A little better. All right, so this is practice packet page 14. Here is number 1. It says, according to the Bronsted-Lowry theory, and again, on the Regents, it's going to call that probably the alternate theory. So according to the alternate acid-base theory, what does H3O plus act like in the following reaction? So we have our reaction here, but what we have to remember is the alternate acid-base theory defines an acid as the proton donor, and it defines the base as the proton acceptor. So we are looking for where the hydrogen ion goes, okay? So what does H3O become on this side? Now, for these reactions, these are called net ionic reactions. It's not really the full reaction that we're looking at. We're just looking at where does the hydrogen ion go. So we start off as H3O. The other side is going to be either one more hydrogen or one less hydrogen. So H3O cannot become this guy because there's carbons and oxygens and more hydrogens in there than just a difference of plus or minus 1. So it has to go with this one because that is a difference of one hydrogen ion. So H3O plus becomes H2O. How does it do that? It loses. It goes from 3 hydrogens to 2 hydrogen. So this is and I'm sorry, not just hydrogen, but hydrogen ion. This is a hydrogen ion donor, also known as an proton donor. So this is an acid. Okay? Number 2, let me lower you guys down a little bit. Yeah, that didn't work out that well, so apologies. Number 2, according to the Bronsted-Lowry theory, or in other words, according to the alternate acid-base theory, what does H2O act as in the following reaction? Okay, so we have to figure out what H2O becomes. So we're looking for a difference of a hydrogen ion. H2O becomes H3O. That is a difference of one hydrogen ion. And was it lost or gained? It goes from 2 to 3. So the hydrogen ion was gained, also known as accepted. So this is my hydrogen ion proton acceptor. So it is a base. All right, number 3. Can you guys even see number 3? No, you cannot. I gotta lower you down further. There you go. Sorry if that made you dizzy. All right, so we have NH2 plus H2O yields NH3 plus OH negative. According to the alternate acid-base theory, what does NH3 act as in the following reaction? So NH3 is a product, right? So it's not going to be the acid and it's not going to be the base. It's going to be a conjugate acid or a conjugate base. So whenever we're talking about a product, we have to think of it in the reverse, and the reverse means conjugate. Okay? So what does this one partner up with? We're looking for a difference of a hydrogen, right? So it can't be H2O because that's not a difference of just a hydrogen. So it's got to be the NH2. Okay? If you want to think about it in the reverse, think about it in the reverse. But now that you have these two connected, you can think of it in the forward and remember that that's going to be a conjugate. So how does NH2 ion become NH3 Well, it gains or accepts. So this is my acceptor, a hydrogen ion. Okay? Which means this is my base. And a base is always connected to, remember I was telling you in my last video, you always need an ABC. So a base is connected to a conjugate acid, which means NH3 is my conjugate acid. So NH3 is actually an acid in the reverse. Okay? Hopefully that made sense, because NH3 going in the reverse direction loses a hydrogen ion. It goes from 3 hydrogens to H2, 2 hydrogens. So losing is an acid. All right, let me flip this thing around. It's easier to flip it than right on my knees, although I was on my knees for that last one. My husband's like, why is it upside down? I'm like, mind your business. Okay, number 4, H3O plus and OH negative, H2O and H2O. We have the same products over here, so it does not matter how you link these two, okay? It doesn't matter at all. They're going to get linked to a water, so whatevs. But I lost the question, sorry. According to the alternate acid-base theory, what does H3O act as in the following reaction? So just hook this guy up to one or the other. It does not matter. But it's going from H3 to H2. So therefore it is losing or donating a hydrogen ion, also known as a proton. So the losing one or the donor is an acid. So 4 is acid. All right, number 5. According to the alternate acid-base theory, what does Cn minus the Cn ion act as in the following reaction? All right, so what does this become? We're looking for a difference of 1 hydrogen. So there we go. We're going to connect these two. What's happening to the hydrogen? We do not have a hydrogen here. We have a hydrogen here. So that means it gained, which we call that the acceptor, the hydrogen ion or the proton acceptor. I'm so sorry if this is blurry for you guys. I really can't, I don't know what to do about the light. I have all kinds of lights in here and they're just all blurring. So I hope you guys can see it. Anyway, sorry, the acceptor is a base. So when it gains a proton, that's a base. All right, number 6. According to the alternate acid-base theory, what does CH3COOH? CH3COOH. Make sure you grab the right one. It's talking about this one. Act as in the following reaction. So what does this guy become? We're looking for a difference of 1 hydrogen. So it becomes that guy. So what happened? We have 3, 4 hydrogens here. And we have 3 and 2. We have 5 hydrogens here. So this is a hydrogen ion acceptor. Acceptor, I don't know. So I don't teach English. So this guy is a base. Okay? All right, on to the next page. On to the next page. All right. Page 15. Let me do this one. I can't get down that low. Come on up here. Let's see if that works at all. All right. Kind of glary. I'm sorry. All right. Page 15, number 7. According to the alternate acid-base theory, also known as the Bronsted-Lowry theory, what does HCN act as in the following reaction? So HCN becomes Cn minus. There is a difference of one hydrogen here. We have a hydrogen here. We do not have a hydrogen over here. So therefore it lost or donated. And a hydrogen ion donator is an acid. So HCN acts as an acid. Number 8. According to the Bronsted-Lowry theory, what does NH4 plus act as in the following reaction? NH4 plus becomes NH3. How do I know it becomes that? Because that is a difference of a hydrogen ion. Okay? So it goes from 4 hydrogens to 3 hydrogens. That means it is lost. So an H plus was donated. And that is your acid definition. Acid is when a proton is donated. Number 9. HCl plus. I don't even know what that is. Aluminum something or another. Okay? What does the aluminum something or another act as in the following reaction? All right. So we have lots of hydrogens over here and hydrogens over here. How many hydrogens do we have? 2 times 5 is 10, right? Plus 1 is 11. How many hydrogens do we have over here? 2 times 6 is 12. So we have 11 hydrogens here. We have 12 hydrogens here. So what happened? We gained a hydrogen ion. And when a hydrogen ion is accepted, that makes this the base. If that was too challenging, okay, the other one is pretty easy. Look at the other one. Hydrochloric acid becomes a chlorine ion. Has an H, does not have an H, lost a hydrogen ion. So this one is losing. That means it's the acid. That means this one has to be the base. Okay? All right. Take a look at the challenge problems. They're challenge problems because there's an actual, a full written out equation here. So it's not just as easy as looking for the hydrogen, but honestly, these are just as easy, but you're just looking at the whole equation. So if the challenge problems are really confusing you, don't worry about them. Okay, don't worry about them. I'm going to show you how to do one, and then I'll post the key for all of them. So if you want to try to challenge yourself and do them, that's great. If you're totally lost, please don't worry about it, okay? No stress here. All right, so we have hydrochloric acid plus sodium hydroxide. So guys, look at this. We've got an acid plus a base. Acid plus a base. This is a neutralization reaction. It is also called a double replacement reaction, right? So double replacements, you take the outsides and put them together, and then you take the insides and you put them together, right? But we already know that we have an acid and a base, and an acid and a base neutralization reaction always makes water and a salt. Okay, I just wanted to point that out, all right? But you already know in this one. This one's an acid, this one's a base. You already know it, acid, base, okay? So heck, you can go ahead and mark those. That's your acid, that's your base. Whoa, no, don't fall over. Okay, so the trick becomes, what is connected to what? Okay, so let's follow the hydrogens. This guy It's an acid, right? So it's going to lose that hydrogen. That hydrogen is going to join that hydroxide and become water, right? This chlorine is going to join the sodium and become NaCl. So let's see, what was I going to say? Our acid is going to be paired with this one. And our base, I should need it, is going to be paired with this one. Okay? That's the tricky part, and that's the part, like, it's okay if you don't get that part. Okay? I'm not even going to explain why. You just see if you can do the other ones. Oh, okay, sorry. I forgot where I was. Squirrel. All right, so an acid is always connected to a conjugate base because we need A, B, and C together. A base is always connected to the conjugate acid because, again, we need A, B, and C all together. All right. See if those make sense to you. Again, I'm not too concerned. I don't really want to explain the challenge problems to you guys on a video because you can't ask questions and I can't see how you're doing, and I don't want to stress you out. So if you don't get that, don't worry about it. Again, if you want to try it in pencil. I'll give you the key. You can look and see how you did. And if you did great, awesome. If you did bad, don't even worry about it. Okay? Hopefully that helped you guys, and hopefully this video uploads. So fingers crossed. You guys have a good day.